derivation of integration of secant x dx. Okay, so in this integration, say we need to multiply and divide by secant x plus tan x. So here we are multiplying and dividing with secant x plus tan x. So when you're multiplying the same thing in the numerator and the denominator, it is nothing but indirectly we are multiplying by 1. So we are not changing the value of the given trigonometric function there. Okay, so now when you expand the numerator part, so what is that we are getting? We are getting it as secant square x plus secant x tan x. And with a dx in the numerator part and the denominator part as it is, so which is nothing but secant x plus tan x. Now looking at the numerator part, what we understand is if you take the denominator as t, the secant x plus tan x as t, and when you differentiate it, you are getting the numerator part. So therefore let us assume secant x plus tan x as t. Okay, so now when you differentiate secant x plus tan x, you are getting it as d by dx of secant x is nothing but secant x tan x, and when you differentiate tan x, you are getting it as secant square x. Okay, so we are differentiating with respect to t, so it will become dx by dt. When you take it to the other side, it becomes into dx is equal to dt. Okay, so now what we observe in the numerator part is this. So can we replace it? So the numerator part can be replaced it by dt, because we got that by t, which we assume. So which is giving us log t plus c. Okay, so when you replace the t with what we assume, so which will give us log the modulus of secant x plus tan x with a constant. Okay, so therefore the final thing can be written as, therefore the integration of secant x dx is nothing but log of log secant x plus tan x plus c.